So today we are going to know about what is merge sort exactly. Merge sort is a sorting algorithm in data structures and algorithms which is famous for its efficiency and stability. I think you know about stability. What is stability? So merge sort is based on a very famous algorithm in DA, which is divide and conquer algorithm. It reduces your time complexity into logarithmic time. More in many cases, not in merge sort, but in many cases. So what is divide and conquer? First, we should know about that. So divide and conquer says we have to divide a particular problem, the main problem which is given to us, into two equal halves, two equal sub problems, and then solve the sub problems individually. After that, we use the solutions of the smaller problems and we find the overall solution. We divide the main problem into smaller problems until we also divide the smaller problems too, until a particular base case which is given to us, which we decide on our own according to our problem. Divide and conquer is basically used in merge sort, quick sort. These both sorting algorithms are based on divide and conquer only. That's why their time complexity is really good in comparison of other sorting algorithms, especially bubble sort. It is used in these sorting algorithms, and also binary search is based on divide and conquer. If you know about binary search, then its time complexity is log n, so it's based on divide and conquer only. We divide the array into two parts and then we search. So we were talking about merge sort. What is merge sort? So in merge sort also we use divide and conquer. We divide the particular main problem into two halves, and then we'd sort the two smaller arrays, two equal halves of a main array individually, and then the sorted versions are merged together into a single array. We keep dividing the main problem into smaller problems until we get one element only as a leaf. जब तक एक एक एलिमेंट नहीं रह जाएगा डिवाइड करते करते, तब तक वी विल कीप डिवाइडिंग इट. Let me show you an example. So we have taken this array. This is an input array. We are given with the main problem. So we'll use merge sort on it. We first divide this array into two parts. So these two parts are 7, 0 and 3, 1. After that, we still see this is a bigger array. Then we'll again divide it into two halves, which is 7 and 0, and this into 3 and 1. Now we have got single elements after dividing the main problem. Now we'll apply we compare the elements with each other and then sort them. So we'll compare these two and we'll get the answer as 0 is smaller than 7, then 0, 7 is the answer. Then same we'll do with 3 and 1, which is 3 is smaller than 3, 3 is smaller than 1, and we'll get 1, 3. Now we'll apply the same thing on this also. We are merging it. This is the merge algorithm. This is the divide algorithm, and we are conquering here, solving them. We are conquering them. After that, we are merging these two. We are conquering here also. This solution is 0, 1, 3, and 7. This is our answer, and the time complexity in this is n log n. Now, as I have shown you how this algorithm works, now let me tell you what is the time complexity. I have already told that the time complexity of this algorithm is n log n, big O of n log n. Why is that? So log n, I have already told you, log n is because if you have learned about binary search, you may be aware of this. Whenever we divide a problem into two halves, n by 2, n by 2, n by 2, by using the master's theorem on it, we get the time complexity as log n. I'll explain it further in any other video. And this dividing thing gives us a log n time complexity. So why is there an n log n? So there is an n log n because whenever we compare the elements with each other and sort them, this takes an overall, not always, but around a complexity of n. even when you reach the second case, when we have a two equal halves and they both are sorted, when we compare them to each other and sort them, we'll get a n by 2 minimum. So by any time complexity theorem, we'll get the time complexity is n while merging them. So merging two arrays gives us a complexity of big O of n, and dividing them gives us big O of log n, and combining both of them gives us a time complexity of big O of n log n. So this is it. You can also prove the we can also find the time complexity of merge sort using Master's theorem. It is Master's theorem. It is taught in DA, Design and Analysis of Algorithms. Thank you very much.